In this video, we're going to look at another variation of the ideal gas law that we can derive from some of the other equations that we've dealt with this semester. So density and molar mass of a gas can be related using the ideal gas law and other equations we've learned this semester. So I'm going to start with the density equation and the ideal gas law. So we know that density is given here, right? Density is mass over volume. And what I'm going to do is I'm going to solve the ideal gas law for volume. So I need to divide both sides by the pressure. So volume is equal to nRT over the pressure, right? And then I'm going to take this expression for volume and plug it in here in the density equation. So that's going to give me density is the mass over, and then the volume is nRT divided by P. So P should be in the numerator. Right? And then the other thing I want you to notice is the formula for molar mass is the mass divided by the moles. And I have the mass divided by the moles here. So I can replace the mass divided by the moles with the molar mass. And so that gives us an alternate form of the ideal gas law where density is equal to molar mass times the pressure over RT. And so this gives us an equation that relates the density of a gas to its molar mass. Now, this is the form of this equation that is given on our equation sheet. So that's the one that I'll probably show most often, but we can also rearrange that. If I isolate the molar mass, then I can write the molar mass is the density times RT over P. And so these are both the same equation. I've just rearranged it. And they're both great to use. You can use whichever one you like best, but this is the one that you'll find on your equation sheet. All right, so let's do an example, and then I have a couple videos with some additional examples. So we want to know the density of gaseous hydrogen if the pressure is 1.32 atmospheres and the temperature is negative 45 degrees Celsius. All right, so from the last slide, density is molar mass times pressure divided by RT. So they told us this hydrogen gas, so I know the molar mass of H2 is 2.02 grams per mole. The pressure they gave us is 1.32 atmospheres. The temperature, so it's negative 45 Celsius. So I need to add 273 to get that in Kelvin, and I get 228 Kelvin for the temperature. So I think all I need to do now is go ahead and plug in these different values, and then I just need to be careful of the units, right? I didn't talk about the units on the last slide. Let's see how the units come out for density. So density, the molar mass, I have 2.02, and again, I think I'm going to put in all the numbers and I'll work the units off to the side. So the pressure is 1.32. We have R, and the temperature. And so for my units, the molar mass is grams per mole. The pressure is atmospheres. And R is on the bottom, and I have liters times atmospheres, and then the mole and the Kelvin will go on the other side of the divisor, and the temperature is in Kelvin. So Kelvins cancel, moles cancel, atmospheres cancel. And so we can see the units on the density, in this case, is going to be grams per liter. And in fact, that's what we usually like to use for the density of a gas. And so those will be my units. So when I plug all of that information in, I get for a density of 0.143 grams per liter. All right, and we've got some other examples on some follow-up videos.